kidney disease and also how chronic kidney disease affects high blood pressure. High blood pressure can constrict and narrow blood vessels and also weaken them. Now, this is what you have to understand, right? Understand that high blood pressure can constrict and narrow blood vessels and also weaken them. High blood pressure over time can damage blood vessels throughout your body because blood pressure is the force of your blood against the walls of your blood vessels around your body as your heart pumps. High blood pressure could reduce blood supply to the kidney and it could also damage the nephrons in the kidney. As a result, the kidney will stop removing waste and extra fluid from the blood, and this extra fluid in your blood vessels will build up and raise the blood pressure even more. If your blood pressure cannot be maintained, your kidneys will continue to get damaged. And by your kidneys playing a key role in keeping your blood pressure in a healthy range, the damaged kidneys are less able to regulate the blood pressure, and a consistently high blood pressure will make the kidney damage worsen, which will make your chronic kidney disease worsen. And then the kidney will not be able to regulate the pressure because the kidney is damaged and the renin-angiotensin system will be damaged, and therefore you will continue to have high blood pressure, leading to more damage to the nephrons in your kidneys, and the cycle continues. Understand that?
Yes, miss.
Okay, everybody who understand, raise your hand or send a thumbs up.
Mr. could send us my recording after, please.
Again, that was something I write down. So okay. Now, yeah, but so my notes, as I say, my notes I just try to make things simple. You understand? It's no, yes,
Miss,
it is.
excuse, I now came in, so I don't have a clue what's going on.
Well, we are just going through the relationship of hypertension and chronic kidney disease. So somebody could explain what is the relationship between high blood pressure and chronic kidney disease to Miss Medina?
All right, so I'm gonna try shortly in a short version. I'm gonna try. So when you're suffering from high blood pressure, the pressure of the blood affects your blood vessels, right? And what it will do, it goes to the kidneys and it damages your nephron.
Nice.
When it damages your nephron, filtration is impaired. System is impaired, and toxins and excess, waste material is what is supposed to be filtered out is not. It goes straight back to the bloodstream,
Nice.
right? And from there, the whole cycle continues because the pressure continues to be high, damaging more nephrons, going back to your bloodstream. If you don't control it, you're going to end up getting kidney failure.
Right, and with the kidneys being damaged, it will be unable to control the blood pressure because the kidneys are responsible for the renin-angiotensin system. So therefore, the blood pressure will cannot be controlled, and the nephrons in the kidneys will continue to be damaged, creating a whole cycle.
Yeah. One thing I was looking at, it just jogged my memory there. The damage, part of the damage to the nephron comes with inside the Bowman's capsule, it starts to harden, which affects the filtration.
Yes.
And from there, the particles that are supposed to be filtered out goes back to the bloodstream. I can't remember the thing for it. What is wait is just now. So
I don't know something.
I can't remember. It. Something that is responsible. I can't remember it. The mother might have fight up myself tonight. But I read it last night. Anybody else can help me?
No, just hold 1 minute, right?
Sorry, I kind of on work, so I don't have my books or my notes in front of me, just my phone. So I call it from off the top of my head.
Angie, I didn't hear if you mentioned that it constricts and narrows the blood vessels as well.
He
which
said
seem
that.
to be important. Okay.
Yeah, he said
Right.
that.
Okay, I was interrupted backwards. Andrea, you can just repeat the question?
I said I can't remember what do you call it when inside of the Bowman capsule where the filtrate supposed to pass through, it starts to harden. That is part of one of the
The
Glomerular
glomerular membrane.
close.
The
right.
glomerular.
It starts to harden,
So
Yes.
which prevents
calcification.
proper filtration. That is
Yeah.
what is. So when it hardens, it affects filtration. So that's
That
where
does
the
happen with
toxins
diabetes.
goes
Yeah.
back to the bloodstream through the efferent artery.
Yeah. Okay, so that's hardening. That's how that hardening has happened with diabetes, and then like we're coming up to that next.
Okay.
So yes, because all of them connected.
Thanks, Nicole. Glomerular sclerosis.
Yeah, so that hardening has happened with diabetes, with nephropathy. Or am I wrong? Yes, it happens with diabetes also. Okay, so Miss Medina, you understand what you was now going through?
Yes, miss. Yeah, miss, I understand.
Okay. Yeah, so I don't want to go through the RAS system because that's well right now because there's a whole next thing with the angiotensin turn into angiotensin 1, then with the ACE inhibitors come and cut the angiotensin 1 and make it into angiotensin 2. You know? So I don't want to confuse you guys with that. I just want you all to get like the basics on the relations. Okay? So seeing that we went over the hypertension and chronic kidney disease, then we could go to diabetes and chronic kidney disease. Everybody get rid of the hypertension and chronic kidney disease relationship.
Yes, ma'am.
So I'm speaking
Yes,
to myself.
miss.
I have one
Yes,
question.
miss.
Who
I
have
have
a
one
question?
question, my lady. What you just explained there, is that the exact, that would be the exact answer for a question, right?
It could be.
No, well, I trying to figure out because I've seen a whole long paper and just enough in about a few minutes you just explain everything. So I think we should take
It's
I think
basically,
it's
I just shorten it. Well, together with that together with the I will also let me see. I will also add in the renin angiotensin system. Yeah, and that should give you a full answer.
because it's kind of hard to understand if you don't. Well, for me, if I don't see the physical system. So whilst you are speaking, I am actually seeing the arteries going into the nephron and the damage that is being done. And again, I better understand it by actually seeing it, how you
Right.
explain it. But if I just read it and I read something and I don't know how it happening, I'll be lost. So that's why I have to go and watch videos.
Okay, right, and that's why we're here, right? So you can understand. So yeah, is what we're going through, and then well, I'll send you all the renin angiotensin system. And that's an essay that I like you want to practice the relationship between chronic kidney disease and hypertension, right? And now we're going to look at the relationship with chronic kidney disease and diabetes. So, chronic kidney disease, and diabetes. How are these two related? Anybody wants to put up their hands to answer, volunteer? Or I'll just have to pick somebody. So I'll just pick somebody. Miss Jessup, are you online? Miss Jada?
Yes, I am.
Probably
Can
not.
you repeat the question, please?
Can you tell me the relationship between chronic kidney disease and diabetes?
Um, I can try it because it's something I'm currently actually trying to review. Diabetes, as we're aware, is a problem where we have, well, you have diabetes type 1, type 2. You could have type 2 where glucose is very high and your insulin sensitivity. And so it's high in your blood. And sometimes that could also contribute to blood pressure because you have more molecules in the blood. Type 1 is where you're not producing enough, you're not producing insulin. So there's a problem there. Glucose is a molecule that is not supposed to be filtered by the kidneys. It's not supposed to cross the membrane. I believe if there is an issue with the membrane, glucose could be filtered. It's not a topic that I have mastered as yet.
Okay, well, that's really good, Miss Jada. I don't know why I stopped. So anybody else want to give it a try? So nobody read the handout?
Yeah.
We read it, but it have like stage 1, 2, 3, 4, 5.
Yeah, it don't matter. It don't matter. That was just explaining how bad the nephropathy could get. You understand? So, adding to what Jada said, because I seem like a little confused. So everybody who confused, put up the hand. So nobody ain't confused.
Well, see, let's see, we hand up.
Okay, I see a few hands up. Right, so then that means the rest of you, all your hands not up, then you're not confused, so somebody could give me another answer.
Okay, I would just say what I would relate so far. Basically, diabetes has the ability to increase your blood pressure and hypertension because glucose, as I said before, is a molecule, and a lot of it in the blood can increase your blood pressure, which is basically blood flow against the resistance of your arteries, of your or your blood vessel wall. So if I have more solute in a concentration or in a solution, and if there is a arterial wall, I am basically applying more pressure to that wall, which can damage that vessel and allow molecules to be filtered by the kidneys and are not supposed to be filtered. And as we know that hypertension and those things going into the nephron can damage the nephron and cause damages in any way. Sugar shouldn't be everywhere in your body. That's what I understand from it.
Okay, Jada, no, yes, you have the concept of everything. You have everything, you understand. Yes, and to everybody, like what Jada is saying, that is totally correct. So I just want to add on to what Jada is saying, right? Because yes, what insulin does is insulin decreases the level of glucose in the blood, right? And we all know when you have diabetes, you have to take insulin, right? What glucose is? Glucose is food for the cells of the body, right? Glucose is food for the cells of the body, and what insulin does is insulin facilitates the diffusion of the glucose from the bloodstream to the cells. If the insulin cannot be transported into the cells will starve, right? And we all know that with type 1 diabetes patients have an insulin deficiency. Everybody understands so far.
Yes.
Are you with
Yes,
me?
miss.
Yes, miss.
Sarah, excuse me, could just repeat
Yes.
that last part where you said glucose is food for the cell, and if insulin cannot be transported, then what would happen to the cells? They would what?
The cells will starve. The cells will
Okay,
starve,
okay.
right? After glucose is, I said glucose is food for the cells of the body, and insulin facilitates the diffusion of glucose from the bloodstream to the cells. So it just is like you need insulin for glucose because the insulin is what making the glucose go to the blood cells, and the glucose is what feeding the blood cells. Understand, Tiffany?
So when the
Getting there.
cells start to starve, that is where you call neuropathy.
So this is that is where coming in. So kidney disease caused by diabetes is called diabetic nephropathy, right? And this is it is a compilation of the small blood vessels that feed the kidneys brought on by damage to the glomeruli, also known as glomerulosclerosis. I want to just pause right there. So that is why when we was talking about high blood pressure and then Andre come in and he started to talk about the hardening, right? Yeah, we were talking about glomerulosclerosis because all is connected, and now Jada came and she spoke about
I'm sorry, I have no books on me. I just talk on the top of my head.
yes, I understand. And then Jada came in and she was speaking about the nephrons being damaged and whatnot, and she also mentioned the high blood pressure, so it is related to diabetes. So yes, so when this happens, right, the kidneys get damaged, right? The vessels in the kidneys get damaged, right? The small vessels, because why? Remember, it have an insulin deficiency, right? So therefore, the glucose not really getting pushed into the cells and the cells starving, so therefore it's not really feeding the kidney, these little blood vessels in the kidneys, right? And it's getting damaged. It brings on damage to the glomeruli. And this damage is known as glomerulosclerosis. And what is glomerulosclerosis? Glomerulosclerosis is a fibrotic thickening of the glomeruli. As the disease continues, the glomeruli loses the ability to effectively filter blood. So when you have this thickening in the glomeruli due to the diabetes, right? So it's due to the diabetes because you have less insulin, so therefore the cells starving, right? You have less insulin, so you're not getting glucose pushed into the cells, you understand, to feed the kidney, and then this
Excuse
thickening
me.
of the walls start to happen, yes?
Excuse me. Somebody's in the waiting room.
Let me
Yeah,
see.
yeah.
Okay. So now we have you have this build up, right? And this thickening in your glomeruli, right? And as the disease continue, the glomeruli, it does lose the ability to effectively filter the blood, because remember the walls will have like little pores, you understand, that is filtered. So if the glomeruli start to get hardened, right, then the ability to filter the blood is go lost. It's like when you have rice in a strainer, it's like you have rice in a strainer, right? But you put the strainer and then you pack cloth, it have an extra coating, right? So it's like it making it harder for the water to come through, plus the rice, you understand, and all these stuff. And you understand? And this will cause a buildup of waste products in the blood.
I say I got bumped out. I
Excuse?
miss a lot of what you say because I got bumped out and I'll get back in.
Okay, so we are talking
I
about
say
the
I missed a
relationship.
lot of what you said because I got bumped out and I.
What she's trying to explain. Let's
Okay, so basically what I was explaining, or what I am explaining, is the relationship between diabetes and chronic kidney disease, right? And I started off, well, I don't know if you was here when Jada was speaking about diabetes, how it affects the kidney, right? And then she also spoke about how it leads to high blood pressure because it does have hardening in the glomerulus, right? So I was explaining how it happens. So when a person has diabetes, we have to understand that they lack insulin. So that's why somebody with diabetes, or they have to take insulin, and their glucose does be high, right? But we have to understand the use of glucose and what is the purpose of us having glucose, right? And glucose is the food for our cells in the body, right? And the insulin, what it does is that it does react with the glucose and facilitate the diffusion of the glucose from the bloodstream into the cells. So cells need glucose, right? And in order for the cells to get the glucose, we need the insulin, and the insulin does help the glucose to get into the cell. Okay? You understand that? Miss Kadira?
Yeah.
Everybody else with me on that, right?
Yeah.
Right.
Yes, miss.
Yes, miss.
So if insulin cannot be transported into the cells will starve. With kidney disease caused by diabetes, this is called diabetic nephropathy. And it is a compilation of the small blood vessels of the kidneys brought on by damage to the glomeruli. Right? So it is a compilation of the small blood vessels that feed the kidneys brought on by damage to the glomeruli, also known as glomerulosclerosis, which is fibrotic thickening of the glomeruli. So it's where the basement membrane of the glomerulus, it does start to harden, right? So it does make it harder for blood to filter through, right? As the disease continues, the glomeruli loses the ability to effectively filter the blood. Now, the reason why the glomeruli will lose the ability to effectively filter the blood is because remember the basement membrane, it getting harder. You understand? And this causes a buildup of waste products in the blood, such as urea and creatinine. Because remember, urea and creatinine, this is supposed to be waste products that is being passed out in urine, right? And now the membrane is so hard and it continues to be thickening that this cannot be passed out. So instead of it go out of your system, it is like it's staying into your system. Everybody with me?
Yes, miss.
And
Yes,
I
miss.
thought I was speaking to ghosts.
Yes,
Okay.
miss, we understand.
Yes, miss, we just have to stop and tap the screen to unmute the mic, you know. That's why it just take us
Okay.
a second to answer.
Okay. So we continuing. So diabetic nephropathy, it mainly happens in type 1 than type 2 diabetes. Diabetes, it causes a hyperfiltration in the afferent arteriole. So I remember where the afferent arteriole is, just as you're coming into the kidney, right? Um, Now, the reason why this hyperfiltration does happen is due to the dilation of the afferent arteriole. So the afferent arteriole again smaller with the person that had diabetes, right? I can remember the blood not getting the glucose, it's not really feeding. You understand? And this when this blood vessel it becomes smaller, it causes like a hyperfiltration, right? And due to the force, the amount of force that the kidney putting in, or well, that arteriole, I should say, putting in, right? This causes the kidney to swell, right? And the swelling of the kidney is called. Somebody could tell me what is it called? What is called swelling of the kidney?
Miss Renal,
Anybody can tell me? Excuse?
Miss Renal hypertrophy.
Nice, great. Yes, it is called renal hypertrophy, right? Because the hyperfiltration that is happening here, it injures something called your mesangium in your glomerulus. You understand? That's right where the afferent by the afferent, you know it had the afferent arteriole and it's coming into the glomerulus and then it have the efferent arteriole extending out. So that part right there right there between the joining of the afferent arteriole and the glomerulus there, there's the mesangium of the glomerulus, right? Mesangium, mesangium. I don't know, Dr. Michael told you all about them stuff. Anybody, or I just lost all, yeah? I just
I
want you
can't
all to get
recall.
I just want you all to get the picture of where the hardening and the glomerulus does start, right? So the glomerulus, it will get thickened or
Miss,
hardened.
you can spell that word again, please.
MESANGIUM. So the
Thank
hyperfiltration,
you.
it injures your mesangium in your glomerulus, right? And the glomerulus will continue to get hardened with this membrane. The mesangium is a membrane, right? So the glomerulus, it will continue to get hardened with this membrane being damaged, right? And then molecules that normally will not pass through, it will start to pass through, right? Because remember, the wall now damage is like it starts to break up now, right? And this will cause a leak in albumin.
So, Miss, like it cause a hole in the strain, huh?
Yeah, it's like it build up all that plaque, and then it just break. Yeah. So instead of getting a proper strain, like they just getting this big gush.
Miss, how
Understand?
you mentioned just now? I think so. Let's talk about this, please.
So when it make this big break now, right? Then the leak of albumin from the blood into the urine does happen because remember albumin supposed that is protein. It's supposed to be going back into your bloodstream, right? So this not supposed to be coming out, but remember the glomerulus and the Bowman's capsule. So the Bowman's capsule holding the glomerulus, and the glomerulus is what is be filtering all the blood, and then the filtrate does come out in the little Bowman space, right? So if the glomerulus mash up, it's not really filtering properly, right? And it come like it break. Then the protein was supposed to be going to your bloodstream, again it leaking out, so it's going in the filtrate, and that filtrate is going to be urine, right? So now the albumin, which is the protein, it's going into your urine, right? And when albumin go into your urine, it is called, tell me something, when albumin in the urine, what it is called? Anybody know, I want to answer, can answer me?
What's the question? I'm sorry, I work, so I was in and out. What was the question?
When there is albumin in the urine, what is it called?
Protein.
Microalbuminuria.
Yes, a microalbuminuria,
Microalbuminuria.
right? So now you have microalbuminuria, right? And now that you have microalbuminuria with chronic kidney disease, your glomerular filtration rates continue to drop, right? And the microalbuminuria continue to increase. The reason why glomerular filtration rate continue to drop is because the glomerulus damage, right? So therefore, the rate at which it used to be filtering your blood, it's not filtering your blood properly. So your glomerular filtration rate decrease, right? And your albumin continue to seep out, so your albuminuria increase, right? And now you have advanced nephropathy because it's really bad, right? And when a patient reach now to the end stage renal diabetes, you understand? And well, when a person have end stage renal disease, you know that every night is not 120 days. A normal person blood cells just die after 120 days. A chronic kidney disease patient, their blood cells just die after every 90 days. So after this every 90 days, when this patient blood cell die, right, it have the the glucose that is attached to the blood cell. I'll say it like that, right? It has glucose in the blood cells, right? Because remember, the insulin pushing the glucose in the blood cells, right? So it has insulin, it has glucose in the blood cells. So the glycosylated hemoglobin, when these blood cells die in the chronic kidney disease patient, because this patient is now on stage 5 chronic kidney disease, because the cycle just continue to get worse, the basement just continue to harden, right? And this person is now on stage 5 chronic kidney disease, and their blood cells are dying after every 90 days. So therefore, glycosylated hemoglobin is released, and this is also known as HbA1c. That's why diabetes patients just have to go for HbA1c test, right? And you see now, with that being released, the HbA1c levels will continue to rise, right? And your diabetes will get worse. Your HbA1c levels, when your glucose levels in your blood will continue to rise, and it will continue to get worse because you have diabetes, and your body can really fight off all this glucose that being released into your blood. You understand? Because they don't really have the insulin. Your body not really producing the insulin because remember you have diabetes, right? And therefore the glucose concentration in the blood will continue to be higher, and it will continue to cause damage to the kidneys, right? And it's a whole cycle. So I understand. Or I just
Yes, yes.
that's one person. Only one person
Yes, miss.
understand.
Yes, ma'am.
Yes, yes.
Yes, miss.
Yes, ma'am.
So with the hypertension, you will see how it is a cycle, and now with the diabetes, you will see how it is a cycle. And yes, I went through that whole page and with the stages also. Stage 1 to 5. And Bashara, because we reach back to
Hi, I'm here.
the end stage. As you was talking about the different stages and all kind of stuff.
Yeah, I just said I was on that page currently highlighting.
Yeah. So we just went through all of that.
Yeah, I understand it. It's just I want to know if like we have to remember every single one, right?
It's not a matter of remembering every single one. Watch how easy that was. It's just a matter of knowing
How
how
the processes work from 1 to 5.
yeah how the whole yeah how the how each one need one. The reason why we say relationship is because they are all connected. Just like if you have a partner, you're the partner connected, and it will have things that will correspond and things that would not correspond. So you all have to see if you are related. It's the same way with these diseases. They all have relations. It's just like how you related to your cousin because there's your mother child, your mother sister child, sorry, or your father sister child, your father brother child. Is the same way diabetes related to chronic kidney disease because diabetes does make the glomerular membrane, which is the mesangium, thicken, and it does cause this thickening does cause the glomerular filtration rate to drop, causing microalbuminuria, you understand, and the microalbuminuria will continue to increase because and the glomerular filtration rate will continue to decrease because the diabetes continue to damage the kidney, right? It's just a matter of understanding what is going on. It's a cycle. And when the diabetes continue to damage the kidney, the patient will eventually end up on stage 5, which is end stage chronic kidney disease, right? And a patient, well, everybody, as a matter of fact, have glucose attached to the well in the blood cells. So with a chronic kidney disease patient, their your blood cells just die every 90 days, not 120, it's every 90 days. And with your blood cells dying, it's releasing this glycosylated hemoglobin, So where would the glucose that is released into your blood go? It ain't going anywhere. And you don't have diabetes, so your insulin, it has no insulin to really fight it. You understand? Or to push it into other blood cells. And then your blood cells consistently dying. When they say every 90 days, they don't mean exactly every 90 days, because it's like basically every day. You understand? Is whatever time that blood cell was produced. So when your blood cells continue to die and the glucose continue to build up and your sugar continue to be high, the membrane in the kidney continue to harden, it just getting worse. You understand? It will just be like, it's just a cycle. Everybody with me?
Yes,
Yeah.
miss. So,
Yes,
miss,
miss.
and that will start to damage the other organs in your body as well. The
Yes.
where it does
Yes, because
produce
yes,
glucose,
because it yes, no,
Insulin,
the insulin, the not glucose, the
insulin,
insulin is
the
insulin.
produced
pancreas,
by the insulin is produced by the beta
the
cells of the islets of the Langerhans of the
hypothalamus,
pancreas, right? I don't know if you all knew that insulin is produced by the beta cells of the islets of the Langerhans of the pancreas,
in
and
the
it is
pancreas.
necessary for metabolism of glucose. That is to be understood, right? Insulin is produced by the beta cells of the islets of the Langerhans in the pancreas and is necessary for metabolism of glucose. Insulin decreases the level of glucose in the blood. Understanding how insulin works and understanding how glucose works, it makes you understand how diabetes does damage the kidneys. Because once you understand that the insulin decreases the level of glucose in the blood, yes, and it's related to the pancreas, yet pancreas who had to fight harder to try to make more insulin. So that's how, yeah, it will damage your other organs and whatnot. And you'll just have a whole chain reaction all over. That's how we just have all them other set of diseases.
So, taking most of the drugs for insulin, wouldn't that as affect the kidney as well, or give it scarring, leading to kidney disease?
What? What? Just the first part I can say. We
Ask the question
can
again,
say
please.
I think
the
what you
You ask
mean
person
the
that
that
if
question.
you're taking medication, if it some medication will scar the kidney or help in the kidney
yes,
chronic.
remember the kidney remember the kidney does filter the drugs too, right? But with a decreased kidney function, the kidney can't properly filter anything. You understand? So it's like everything getting messed up because the glomerulus was taken, so it can't properly function. Yeah, you'll take medication, but for how long you'll take medication for? And even though you're taking medication, the kidney still already damaged, and it can't reverse. You understand? Kidney already damaged. You still had diabetes, because diabetes can it ain't curable. So even though you're taking medication, how much okay, so somebody can explain to me um what is erythropoietin and what it does?
Erythropoietin is a hormone that is found in your brain, liver, spleen, and your testes. It also have renal erythropoietin. It is responsible for making more red blood cells and keeping in the bone marrow and keeping it oxygenated and to your organs and systems. Is that correct? Oui?
Yes, yes, okay. Anybody else?
Miss, a hormone produced by the kidneys that stimulate red blood cells production in the bone marrow in response to low oxygen levels.
Okay, so okay. Anybody else? Everybody, that's just it, right?
Miss
So
Jasmine answered
so
something.
what does erythropoietin production have to do with chronic kidney disease? Yes, somebody was going to answer me.
Miss, could you just repeat that question?
What does erythropoietin production have to do with chronic kidney disease? What erythropoietin have to do with chronic kidney disease? What is that relation?
Well, when your kidneys are
Producing more
damaged,
red blood
it's
cells.
it's going to produce less erythropoietin.
And it leads to anemia.
When it produces less erythropoietin, there's less red blood cells to feed blood cells to oxygenate your tissues and your organs, and dies with the starving and dies only with starving take place of oxygen.
Okay. So So erythropoietin causes the immature red blood cells in the bone marrow to start maturing. We all know this, right? Erythropoietin causes the immature red blood cells in the bone marrow to start maturing. And if you don't have enough erythropoietin and the red blood cells die, the ability to make new red blood cells is affected and you become anemic. Everybody with me?
No, repeat that. It causes immature
Erythropoietin
RBC in the bone marrow to what?
to start maturing. It helps them to grow then. It causes the immature red blood cells in the bone marrow to start maturing. So it's like it has helped them to grow, right? If you don't have enough erythropoietin and the red blood cell dies, the ability to make new red blood cells is affected and you become anemic. So you understand how you become anemic? Okay. So everybody with me there. When the
Yes,
hemoglobin levels decrease, so when you become anemic, your hemoglobin levels does decrease. When the hemoglobin levels decrease, hypoxia, which is a state where oxygen is not available in sufficient amounts at the tissue level to maintain adequate homeostasis. So hypoxia results, right? And this leads to an increased erythropoietin production. Erythropoietin usually exists in the liver, spleen, and testes, but these are not important as the renal erythropoiesis. Why these are not important as the renal erythropoiesis, which is the erythropoietin that is produced by the kidneys? Because after the red blood cells die, every 120 days, the liver and spleen remove the old red blood cells, which are erythrocytes, and the iron is recycled to the bone marrow to make new red blood cells. In chronic kidney disease patients, every 90 days, the red blood cells die, leading to an increase in erythropoietin production. And with an increase in erythropoietin production, it leads to an increase in erythropoietin, and this will lead to an increase in deaths in chronic kidney disease patients because too much erythropoietin in your system could kill you. Everybody understand that?
Yes, miss. I got to go to a bar like that.
Okay, so first you have to understand what is erythropoietin and what it does, right? So erythropoietin, what erythropoietin does is it causes the immature red blood cells in the bone marrow. So you just have in your bone marrow come like a birthplace and a graveyard at the same time, I'll say. Right? Because when the blood cells die, they just go to the bone marrow too. So now the eating bone marrow, it is dead blood cells and eating. Right? I just wanted to get that across. So erythropoietin does cause the immature red blood cells in the bone marrow to start maturing. And if you don't have enough erythropoietin and your red blood cells die, the ability to make new red blood cells is affected and you will become anemic. When you are anemic, the hemoglobin levels decrease, and a decreased level in hemoglobin, hypoxia does occur. And what is hypoxia? Somebody can tell me what is hypoxia?
Hypoxia is a increase in
Low oxygen level.
oxygen level in the blood
Right.
in
Hypoxia is
the
low oxygen levels for the
blood.
tissues, right? Nice. And when this happens, when the hemoglobin levels decrease, hypoxia does occur, right? Leading to increased erythropoietin production because you want to make new red blood cells, right? So your hemoglobin counts will go back up, right? Erythropoietin usually exists in the liver, spleen, and testes, but these are not important as the renal erythropoiesis because after the red blood cells die every 120 days, the liver and spleen remove the old red blood cells, which is erythrocytes, and the iron is recycled to the bone marrow to make new red blood cells. But in chronic kidney disease patients, every 90 days, the red blood cells die, leading to an increase in erythropoietin production. And an increase in erythropoietin leads to increased deaths because too much erythropoietin in your system could kill you. So chronic kidney disease patients are more likely to die, right? Because they have an increase in erythropoietin in the system. You understand? Due to the fact that the blood cells does die in a shorter period of time. So therefore the kidney does have to continue to work to make erythropoietin. You understand? But with chronic kidney disease, your kidney does not be able to even work to make the erythropoietin that you need. You understand? So therefore your blood cells doesn't get a chance to grow. It doesn't have that stimulation. You understand that it needs to grow, and this does cause you to become anemic, right? And when you're anemic, right, your hemoglobin levels decrease and hypoxia does start to occur because you don't have enough oxygen to feed your tissues, right? And it will just continue to try to stimulate the kidney to make more erythropoietin, right? But the kidney not able to make the erythropoietin because you have chronic kidney disease and you'll die. Everybody understand?
Yes,
Yeah.
ma'am.
Okay, anything else anybody don't understand? Any topic else you want me to go through again?
I have a question.
Listening.
So I was going through CVD in CKD, right?
Yes.
And I remember Saturday, Dr. Michael had asked us, what are the other factors that are characteristics of the uremic state? And when I was doing research, well, at first I didn't really get characteristics, right? They was just given symptoms like nausea and these kinds of symptoms, right? But then I went on look again, just some, and I found Jesus Christ, I can't find it. Just some. Right. It said some of the characteristics are fluid overload, electrolyte imbalances, metabolic abnormalities, and physiological changes. Is that correct? Because I wasn't finding anything else.
Yeah.
It's correct. Okay, good. That's all I
Yeah,
just
uremic
needed
is uremic state.
clarification on it.
It's her
Yeah.
restless legs.
Right. I just needed clarification on that.
Yeah.
So restless leg syndrome is a real thing?
Yes, and patients will be standing and they'll be shaking their foot all the time. And can't
Oh,
stop.
I didn't know that was like a real thing.
Yes, it's a real thing. That's why it's there.
Okay,
Because it
cool.
has really happened.
All right, thanks.
Yeah. Hey, everybody good.
Is it just those two
So,
essays we practicing, or we doing
so
anemia as well?
what happened to the it was erythropoietin and chronic kidney disease. That's three
Okay.
essays. And it's
I
the
have
essay
a
was
question.
anemia. How is chronic kidney disease and anemia related? That's another one.
Mister, I have a question.
Yeah,
Can you hear me?
yeah.
Is it possible we can have you for more than Thursdays for tutorial?
You can contact me if you have any problems with your work and I can help you.
All right. Thank you.
I'm available until 8 p.m. every day. On a
Thank,
Sundays,
thank,
Sundays is out of it, Monday to Saturday, from 8 a.m. to 8 p.m. I am available.
thank you very much.
You're welcome.
Goodness. So we have to
Yes.
do 4 essays, right?
Yeah. So I said dual anemia is not a long essay for anemia. Anemia is basically it's still is related to erythropoietin also because it have the feedback system that Dr. Michael used with when the hemoglobin decreases, this leads to hypoxia and erythropoietin production. Erythropoietin exists in the liver and synthesized in the kidneys after after 120 days, the liver and the spleen removes the old blood cells, which is the erythrocytes, and the iron is recycled to the bone marrow to make new red blood cells. With hemodialysis patients with the kidneys not working properly, erythropoietin production is stagnant. You understand? It doesn't happen as it's supposed to, and therefore the patient will continue to have a low blood count. So what are terms used to describe alterations in anemia? Anybody can tell me the terms used to describe alterations in anemia? Nobody. So nobody knows about the pnomochromic and the chromic and cytic. No, I
Now,
didn't say the word. I'm just giving you all an idea.
now you should have.
So terms used to describe
Next essay,
alterations
the
in
terms you said,
anemia: pneumochromic, which is a deficiency in the number of red blood cells; homochromic, which is when the red blood cells are paler than others due to the lack of hemoglobin. Let's have hypochromic. This is when the red blood cells have a high amount of hemoglobin, resulting in darker red color blood. So hypochromic is darker color blood. Oh, hypochromic is paler color blood. Pneumochromic is a deficiency in the number of red blood cells. Microcytic is when the red blood cells are smaller, and macrocytic is when the red blood cells are larger. So those are alterations in anemia. I think you all should learn that.
Just repeat it one more time, please.
It is in the handout. Somebody can tell us what page in the handout the alterations, so the anime characteristics is.
I found it on page 16.
So no, okay, so nobody, okay, nice. So that's it. So everybody understand what we went through this evening? Apparently I'm speaking to myself because I have nobody else beside me, so we can end tutorial now.
Miss, yes,
Can
we
you explain
understand
which
so far.
handout? Which handout?
Chronic kidney disease.
Thank you.
The one with mark therapy on it.
Page 16. The handout for the cell alteration in anemia is page 16 of chronic kidney disease.
Found it. Thank you.
Thanks for your assistance, Mr. Always a pleasure.
So everybody understand everything and nobody do.